Alrighty, number 2 for how to know which equation to use. All right, so highway safety engineers build soft barriers along the sides of highways so that cars hitting them will slow down at a safe rate. Suppose a car traveling at 110 kilometers per hour hits the barrier and the barrier decreases the car's velocity at a rate of 32 meters per second squared. What is the initial velocity in meters per second? All right, so first of all, we need to make sure that all of our units are in meters per second for our velocity. So we're going to start with this 110 kilometers per hour, and we need to put it into meters per second. And then we will have our initial velocity. So we're trying to find that initial velocity. And so we're starting with 110 kilometers per hour. So to convert that into meters per second, I'm going to start by just dealing with the hours part. So if I have hours on the bottom, in order to cancel out, I need to have 1 hour on the top, and 1 hour is equal to 60 minutes. All right, but that's still not in seconds. So now I need to put minutes on the top, so minutes cancel out. And 1 minute is equal to 60 seconds. All right, so we've got hours to cancel out. We've got minutes to cancel out. Now we have kilometers on the top and seconds on the bottom. All right, so now let's go ahead and deal with those kilometers. And the way that we're going to deal with that is we're going to know that 1,000 meters is equal to 1 kilometer. Because I have kilometers on the top, I need 1 kilometer on the bottom. And so then I have 1,000 meters is equal to 1 kilometer. And so that will get these kilometers to cancel out those kilometers. And then all I need to do is multiply across. So I'm going to get 110,000 on the top, and all the units have canceled out except for meters. And on the bottom, I'm going to have 1 times 60 times 60 times 1, which is 3,600. All right. And then the only units left on the bottom are seconds. So now all I need to do is throw that in my calculator, and I get 30.55 going on forever meters per second. All right, so this is my starting velocity. All right, so this is the first thing that I know. All right, so that means I have my starting velocity. So any of these equations, I have starting velocity. And let's read what I'm trying to figure out. What distance would the car travel along the barrier before coming to a stop? All right, so I'm trying to find distance. So if I'm trying to find distance, then that means that I'm going to need an x or an x naught. And if I'm trying to measure distance, I'm going to say that my starting position is 0 meters. So that way my ending distance is whatever it is. Just like your meter stick again, just saying, hey, where's that meter stick start and end? All right, so I'm trying to find x. I don't know it yet. I have my starting position. I said that's 0. All right, so we have all of those. And it says before coming to a stop. All right, so if I'm doing before coming to a stop, stop means that at the end, my velocity is going to be equal to 0. So that means I have my ending velocity. So I have those. And then it says what? No, it says my acceleration. So it says the barrier decreases the car's velocity at a rate of 32 meters per second squared. So that means that my acceleration is going to be negative 32 meters per second squared. All right, so that means I have my acceleration. That's this and that and that. So we're good there. All right, so I don't have anything else. So if I look at this, I do not know anything about time, and this particular question is not asking about time. So this one I need time, so that's not useful. This equation I need time, also not useful. I don't have that. So this is going to be my winning equation because I have everything and it has the variable that I'm solving for, which is this distance. All right, so let's go ahead and rewrite this equation and plug in what we know. All right, so I went ahead and plugged in the numbers that we had identified. I put a final velocity of 0 because it came to a stop. I put my initial velocity as 30.55 meters per second because that's what we figured out in part A. Remember, you cannot use the 110 because that does not have the right units. And then my acceleration is negative 32, so I went ahead and plugged that in. My final position, that X is what I'm looking for, and I said my starting position is 0. So I went ahead and did this. Now I'm going to do some math, just plugging in the numbers. And one thing you'll notice here is that I put the negative 32 in parentheses. The reason why I do that is because I want to remember that it's being multiplied and not end up accidentally subtracting. Just a hint, trick thing that I've figured out. Highly recommend it. All right, so now I'm going to move the 933 to the other side. Because it's added, I need to subtract. So I'm going to subtract 933 from both sides. And then the opposite of multiplication is division. So I'm going to divide both sides by negative 64. And I get an answer of 14.59. And so that is going to be the distance that it went before the car came to a stop. All right. Now for part C, I'm going to go ahead and move this out of the way and do part C for you all. Alrighty, so for part C, I'm going to go through again. I'm going to make sure that I have the variable that I'm solving for. This time I'm solving for time. All right, so that means I need to make sure I have time. So one of these first two equations is the one that I want. I don't want that one because it does not have time in it. And this again, I'm doing until the car stops. So that means that my final velocity is 0. All right. And then acceleration is still negative 32. My starting velocity is still the 30.55. So the second equation is not a good choice for this one, even though it looks like it, because we could use our answer for part B in part C, but I'm going to assume for a moment that we didn't do that part. Especially because if you already made a mistake in one part, you don't want to use the wrong answer. So I would rather start from the beginning and get it right the next time. So I do not know my final position. So this middle equation is not going to work. So I need to use the first equation, that my velocity is equal to acceleration times time plus my starting velocity. I went ahead and substituted in for the things that we knew from the problem, just like before. Now I just need to solve. I'm going to subtract 30.55 from both sides. So I go ahead and do the algebra here, and I get 0.95 seconds for my time to stop. If you have any questions, let me know. I'll do a third video for number 3.